Hello everyone. Today we are going to discuss about linked list theory. So let's start. A linked list provides an alternative to an array based structure. Before linked list we'll use array based data structure. Now we are going to discuss about the linked list and the benefits of linked list over an array. So array has a size limitation. That means the number of elements that can be stored in array are predetermined. Okay, but in case of linked list you can store any number of elements. You do not have any size limitation with the linked list. Linked list is also a linear data structure. In this the linearity is formed by connecting first node to the second and so on to the last node. So a linked list in its simplest form is a collection of nodes. Each node is connected to the next node of the sequence, and these nodes collectively form a linear sequence. So each node in the linked list is connected to the next node in the sequence. So basically what is a linked list? Basically what is a linked list? For example, if you want to represent 8, 6, 2, 3 and 5 in a list, so how you can create that in a linked list? So linked list should be like this. Every node is connecting a data field and is connected to the next node of the sequence. In this way the linked list are formed, and for linked list you do not have to allocate the contiguous memory. Okay, all these nodes are scattered in the memory and they are connected with each other. So the linked list should look like this. This is the first node which is stored somewhere in the memory. This is the second node and so on. So these nodes are not in the contiguous memory, so you can add up any number of node, and to reach any node you have to start from the beginning and going to the next node from there. So what is a node in a linked list? So what is a node in a linked list? In a linked list, each node stores a reference to an object. So in this object we will store data or the information, that is the part of sequence, or that is an element of the sequence, as well as a reference to the next node in the list. So the node will contain two fields, one is the data field and another is the reference field. So every node should look like this. The node will be capable of holding a data as well as capable of holding a reference to the next node in the sequence. So now consider this following sequence, how a linked list will be formed. As we already have seen, so a linked list representation will look like this. 12 will be the first node, 8 is the second and so on. 2 will be the last node of the linked list. 2 will be the last node of this sequence. If you want to add some more node, if you want to add 18, then what you can do, you can create a new node and you can connect this 18 with 2. Now this 18 will become the last node of the linked list. So linked list head or a start. Each linked list instance contain a head or a start reference, because you need a reference to refer to the first node, a reference to refer to the first node. So that reference is known as head. Every linked list must contain a head which refers to the first node of the sequence. Head is not a part of linked list, it's an external reference, so it will refer to the first node like this. This is our head. It will point to the start of linked list. And every node contain data and the next pointer. By going to the next reference of each node, we can find the next available node. and the last node will refer to null because there's no node after this particular node. Likewise, start or head linked list can also contain a tail reference. Okay, the last node of the linked list is known as the tail of linked list. Is known as tail of linked list. The last node of the linked list is the node whose next reference refer to null. Means after that particular node, there's no node, there's nothing after that particular node. So, how you can identify a last node of a linked list? Any node which is referring, whose next reference is referring to null will be the last node. Okay, so we use an special reference in our implementation which is known as tail to refer to the last node. Either what you can do, you can find the last node of the linked list by traversing the linked list, starting from head and moving from one node to another by following the each node next reference. What you can do, you can reach to the last node. And how you identify the last node? A node whose next reference is referring to a null value is the last node. This process is known as link hopping or pointer hopping. So what is this process particular is? Consider this linked list. You can start from head and you can refer to head. You will got the reference of this node in the head, and then you can refer to the next node of the next field of this particular node. If that next field is not null, then you can move to this particular node. Again on this node you can check whether the next field is null or not. If next field is not null, then you can go to that next node. Okay, and in the same manner you will reach this particular node, and on this node when we'll check the next is not null, it will return us false. That means this is the last node of linked list. Okay, by this also you can identify the last node, but this process will require visiting an node. If there are n node in the linked list, then this process will involve an operation, and the complexity of this process will become O of n. Anytime if you want to identify the last node, you have to go through an algorithm which is O of n. That's why we'll keep a reference of tail. To improve the operational efficiency. So, like linked list had, a linked list can also contain a tail reference, but it is not compulsory for linked list to keep a tail reference. Whenever we want operational efficiency, we can include an extra reference in the linked list class or in the linked list implementation which contains a reference to the last node. So keeping tail is not necessary. In some time we keep tail, other we do not. But if you are keeping a tail, it will improve the operational efficiency of your linked list. So tail helps in operational efficiency. Now the another thing that is associated with this size denote the total number of nodes in a linked list. Okay, in any linked list the total number of nodes is denoted by size. So it is common for a linked list instance to keep count of the total number of nodes that are in linked list, which is also known as the size of linked list. If linked list instance do not keep size, then we have to count nodes each time by traversing the linked list for getting the total number of nodes in the list. Okay, now you want to traverse Earlier in getting the last node we are traversing and we are getting O of n complexity for that thing. So again for getting the number of node in the linked list we are getting O of n complexity. So this process will cost O of n each time. It's better to keep size. So we'll keep size in our implementation. Now we'll discuss about the types of linked list. There are three types of linked list: singly linked list, doubly linked list, then comes circular linked list. Circular linked list can be of singly circular and doubly circular linked list. Okay, so there are basically three types, and the circular also contains singly and doubly type. Now, what is a singly linked list? In singly linked list, each node refers to the next node in the list. Means the node contains only a single reference. You can only traverse in the forward direction, one way only. So this singly linked list is known as one-way list also. One-way list also. A singly linked list node contains a data field and a reference to the node of the linked list, a reference to the next node of the linked list. The next reference of last node of singly linked list refers to null. So this is the node, every node will contain a data value and a reference to the next node in singly linked list. So this linked list is a singly linked list where each node is connected to only the next node. Okay, the first node is denoted by head and the last node is denoted by tail. Now what is a doubly linked list? As the name suggests, in doubly linked list, each node can refer to next node in the list as well as refers to the previous node in the list. So doubly linked list contain double references, that is next and previous. In doubly linked list, you can traverse in both direction, forward and backward. Either you can move to the next node or you can move to the previous node of each node. In doubly linked list, node contains a data field, next reference and a previous reference. So the next reference of the last node refers to null and previous reference of the first node will also refers to null. Means the last node's next reference and the previous first node previous reference refers to null. So this is the node representation of a doubly linked list which contains a previous, data and a next reference. The next reference of the last node refers to null and the previous reference of the first node will also refers to null. See, in this figure you can see the previous is referring to null as well as the next is referring to null. Doubly linked list can also contain a tail, but every linked list must have a start or a head. Now each node is connected. This particular node is connected to the next node as well as the previous node of the sequence. So what is a circular linked list then? In circular linked list, the last node is connected to the first node. How? The last node next reference refers to the first node of the linked list. This gives its circular behavior. This gives the linked list circular behavior. From last you can directly move to the first node. Singly circular linked list will look like this. See, the last node in singly linked list refers to null, but in this implementation it is referring to the first node which is also referred by head. So what happens in doubly circular then? In doubly circular linked list, last node's next reference refers to first node and first node previous reference refers to the last node. So this particular thing gives the circular behavior to doubly linked list. Okay, the doubly circular linked list. So doubly circular linked list will look like, see, the previous node of the first, is the last node, and the next of the last node is the first node. Likewise singly circular list. Okay, so in this way we'll achieve the circular behavior in doubly and singly linked list. Okay, so that's all for this introductory theory. We'll discuss implementation time in next video, and we also learn about the operations we can perform in the linked list. So thank you.